Hi and welcome back. In today's video, you're going to learn how to draw the shear diagram and bending moment diagram of a statically determinate structure. If the number of reactions of the supports is equal to the number of the elements in the structure times 3, this type of structure is considered to be statically determinate and can be solved using the three equilibrium equations. In this example, we have this beam, which is supported by a roller at point B and is supported by a pen at joint C. What we have to do is to draw the bending moment diagram and shear diagram for this beam. In order to get started, we should first draw the free body diagram of the structure. To draw a free body diagram, we are going to remove these supports and replace them with the types of reactions. So in here, in the point B, since we had a roller, we will only have a vertical reaction in the y direction. Besides that, for the point C, since it was a pen support, we will have a reaction in the y direction. Besides that, we will have a reaction in the x direction, but since we have no force acting in the x direction, we will assume this as 0. Now, in order to calculate the values of reaction at point B and reaction at point C, we will use the equilibrium equations. The summation of the forces in y direction will be 0. As you can see in here, we have the 10 kN per meter distributed load multiplied by the length of the beam. Since this load acts downwards, the sign will be assumed to be negative. For RBY and RCY, the signs will be positive, since both of them are acting in the positive y direction. The summation of these forces will be equal to 0. From here, we will have an equation where RBY plus RCY equals to 17.5 kN. Besides that, the summation of moment around any point of the beam will be 0. So the summation of moments around support C will be 0. From here, we will calculate the moment created by the distributed load and the moment created by the reaction at point B. Since we are calculating the moments around point C and there will be no moment arm for the reaction C, so we will neglect that one. From here, the value of RBY will be calculated as 15.31 kN. Since we have this equation in here, we will substitute this value instead of RBY. The value of RCY will be 2.19 kN. Now, since we have these values, we will replace the reactions with their actual values. Now, in order to draw the shear diagram and bending moment diagram, what we will do is we will take sections and then we will find the equations for both shear and moment. In the next step, we will substitute the values of the length into those equations and find the moments and shears at each of these points. So first of all, we will take a section before this reaction. So the section will look something like this. The x will vary from 0 up to 0.75 meters. Now in here, we will use the equations of equilibrium. If this value is assumed to be the shear in here, the summation of forces in the y direction will be 0. Since the direction of the shear and direction of the distributed load are both in the negative y direction, from here, V or the shear will be minus 10x. So at 0, we will replace the x with 0. The shear at this point will be 0. As we go to the right side, the value of shear is going to increase to the negative side. Same applies for the moment. We will take the summation of moments around this point, and from here, as you can see, this will be the moment which will be created at this section. Besides that, there will be an additional moment created by this distributed load. The summation of these moments will be 0, and from here, for this moment, we will have an equation which is minus 5x squared. X is the distance from point A. Now, in order to draw the shear and moment diagrams for this one, what we will do is substitute the values of x from 0 up to 0.75. So for the shear diagram and the moment diagram in here, we will draw straight lines at point 0 in here. Since the value of x is 0, so the shear will be 0 as well. As we go to the right side here, up to 0.75, the shear is going to increase to the negative side, and it will create a shape like this. Since the formula for shear was minus 10x, at 0 it will be 0, and at 0.75 meters, it will be minus 7.5 kilonewtons. For the moment will be 0 in here, minus 5x squared, as we go to the right side to here and substitute the value of x as 0.75, the value of moment in here will be minus 2.81 kilonewton times meter. We will have a meter in here. Next, we are going to take a section after the reaction at point B. For this one, we are going to obtain the equations for shear and the moment in the same method that we did previously. So this will be the equation for shear and this will be the equation for moment. Now from this point up to point C, we are going to draw the shear diagrams and the moment diagrams based on these equations. For the shear diagram, the reaction at point B was 15.31 kilonewtons. So that reaction will take this value from here up to here. It will look something like this. And the value at that point will be 15.3 minus 7.5, which will be 7.8 kilonewtons. Again, since we had a uniformly distributed load, this diagram will follow this pattern up to the reaction in point C. Since this length was 1 meter, if you substitute the value of 1 instead of x in the formulas shown above, this value will be minus 2.2 kilonewtons. And since we had a reaction of 2.2 kilonewton at point C, it will take it back to 0. For the moment diagram, the moment will be maximum at this point. In order to obtain the value of x at this point, what we will do is to make this equal to 0 and then solve it for x. The value of x will be 0.78 meters. So for the moment diagram, the maximum moment will be at 0.78 meters. Again, what we will do is to replace the x in here and here with 0.78 meters. As a result of this, the value of moment in here will be 0.232 kilonewton times meter. And again, at the support C, the moment will be 0. So this is how you can draw the shear diagram and bending moment diagram of statically determinate structures. If the content of the video were helpful, consider subscribing to our YouTube channel and following us on Instagram and LinkedIn. Thank you very much for watching.